So hello everyone and welcome to Ask AuxEn Anything weekend session that we conduct. And as you all know that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any steel or RCC design concept or any project that they are doing or construction site issues. So this is the 46th such session that we are conducting, and let us begin by taking the queries that have been asked during this week. So we'll begin by taking the queries from the Google form, and then we will take the queries from the live comments and emails. So the first query is by engineer Komal More. She is a postgraduate student and she is asking. So she's from Sangli, Pune. Pune. I think she must be studying at Pune. So she is asking, I am working on my project of eccentric braced frames on steel buildings using ETABs. Guide me how to generate EBFs with varying link lengths. So eccentric braced frames mean that you will have a bracing like this, and there will be a certain eccentricity over here. So the braces do not connect concentrically; they have certain eccentricities. This type of Oh, did I share my screen or not? I'm so sorry. Is anything visible on the screen? No, I guess. Wait a minute. I think I forgot to share my screen. Right. So let me just take the query once again. This query is by engineer Komal More. She's from Pune, and she has asked this. I'm working on my project of eccentric base frames on steel buildings using ETABs. Guide me how to generate EBFs, eccentric brace frames, with varying link lengths. So I was telling you about this. This is called as an EBF system, where this is the eccentricity. The EBF, this is my bracing, and the bracings are not concentrically connected. They do not concentrically, or they do not coincide at a beam position. Rather, they are separated by certain eccentricity, and this is called as the link. And then this system is a good system to take your horizontal earthquake loads. How? By inelasticity, or I should say by significant deformations, significant shear deformations of this link. We say that the earthquake forces will be resisted by this frame, and by the inelastic shear deformations of this link, significant earthquake energy is dissipated. So in this EBF system, now she is asking how to generate EBFs with varying link lengths. What do you mean by generate? Generate means you will have to you model these different, you model different frames having different lengths. You will have to do that on your own. So maybe this, you model it by E1, then you come up with another frame where the eccentricity is a different value, E2, and so on. So this thing you will have to do on your own. ETABS is not going to generate frames for you. You need to do this thing on your own. Okay. And for each length that you come up with, you can calculate the expected shear strength of each link. You can calculate the expected shear strength of each link. How? That procedure is given, or that formula is given to you in IS 18168. So you can refer to IS 18168, or you can refer to AISC 341. Both these codes give you the calculations for expected shear strength of this link. And once you get that, then you will have to do the expected strength analysis That means you'll have to apply certain force, fictitious force, lateral force, in such a manner that the link reaches its expected shear strength. And at that level, whatever are the axial forces and bending moments in this bracing, whatever is the axial force in this column, whatever is the moment in this beam, you will have to design the other parts of the frame for that. So this is called as the expected strength analysis. So once you come up with different EBF systems of different link lengths, you first find out the expected shear strength by using the formula given in 18168 or 341 AIC, and then you will have to do an analysis which is called as the expected strength analysis. And the procedure I just explained, that you apply a fictitious force in a manner that the shear force in your link reaches the expected shear strength value, and at that level, whatever is the bending moment or axial force in these bracings, whatever is the bending moment in the beam, whatever is the axial force in the column, you will have to design your elements for that. So this is how you can do it. Then our next part of the question is, also I have used built up steel section for columns and I have to go pushover analysis. How to define hinges? I have no idea about doing pushover analysis because I have never done it in any of my projects, or I have not studied much about pushover other than some basic theoretical framework. So I don't know how to carry out pushover analysis. So if someone in the live audience, they know how to carry out the pushover analysis, perhaps they can provide some comments. I think there is this document number FEMA 341 or something, which gives you the guidelines for performing pushover analysis. Although I have not done it myself, so I don't have much idea about it. Anyone in the live audience who have done it and can provide some inputs? Okay, I don't think anyone in the live audience also has done pushover analysis. So for pushover analysis, you please study some other documents that you may get reference from. Okay, yeah. So now the next question is from engineer Manish Parmar, and he is a practicing engineer in Dehradun. And what he has asked, please explain how to decide whether our structural steel column is part of a sway frame or non-sway frame, and then how to find out its effective length. So this is given in your IS 800 2007, the procedure for finding out whether your frame is a sway frame or a non-sway frame. So basically, you will have to, assuming that uh, just a minute. So non-sway frames and sway frames, how to find that out? That is given to you in the chapter 4, section 4, that is. Are you able to see this screenshot? Is my voice audible or not? Just put in some yes, no. Is my voice audible? Okay, so this page is from IS 800 2007, and here it tells you how to find out whether your frame is a sway frame or a non. So you read this: a rigid jointed multi-story frame may be considered as a non-sway frame if the deflection delta over a story height due to notional horizontal loads satisfy this particular criteria. So if you have got a frame, okay, now this we are saying that let's say there are no lateral loads involved in your frame, and then we are applying a certain notional load. So right now I'm not talking about the lateral loads. I am just talking about the dead load and live load. So I apply a notional load, and under the effect of this notional load, if for a clad structure, if for a clad structure where you are not taking the effect of cladding in picture, the lateral drift value, if that is less than h upon 2000, where h is the story height. So between this story height, if you see that the drift value delta is less than h upon 2000, then you will call it as the sway frame. If it goes beyond h upon 2000, sorry, if it is less than h upon 2000, we will call it as the non-sway frame. Non-sway frame if this is less than this. If the delta goes beyond h upon 2000, then it will be called as the sway frame. Okay. When are we talking this? When we apply a certain notional horizontal load. Now, how to find out the value of this notional horizontal load? So that is given uh, in the next page of your code, where it tells you that the notional horizontal loads shall be 0.5% of the factored dead and live load. So this clause, if you are able to see, notional horizontal loads, notional horizontal force should be applied. These notional horizontal forces should account for practical imperfections and should be taken at each level as being equal to 0.5% of factor dead load plus vertical imposed load applied at that level. So your notional loads that you will apply, let's say your factored load is 1.5 dead plus 1.5 live. So you will apply the notional load as 0.005 because it is 0.5%. So 0.005 times this. You will apply it as a notional horizontal load, and then under this effect, you will calculate the lateral displacement, and that lateral displacement you will calculate, and then the drift value should be less than what I just explained. So this is how you will figure out whether your frame is a sway frame or non-sway frame. Understood? If your frame is a sway frame, then the effective length factors will be calculated as per annexure E. I mean, in either cases, annexure E, whether your frame is a sway frame or a non-sway frame, you can go to annexure E and calculate the effective length factors for it. So this is the way in which you have to use the effective length factor method for vertical member design in the ETABS. In the IS 800. All right. Now this method is sort of an old method where you are considering the moment amplification by effective length factors. Okay. Now, if you look at the AISC code now, and if you look at the AISC chapter C, now they have come up with this direct analysis method where they have done away with the effective length method. So now the code tells you that you are no longer allowed to use this effective length method. Rather, you should use the direct analysis method, where instead of this effective length calculations, instead of that, you go for the P delta and P small delta analysis. Okay, along with notional loads and stiffness reductions, along with notional loads and stiffness reductions. So this is the new means this is the procedure that AISC wants you to adopt. It has done away with the effective length based calculation method, uh, which is given in IS 800 as an option. In fact, IS 800 also gives you in Annexure B the other approaches that you can adopt. Okay, of course, one of them is the P delta and P small delta analysis for the vertical member design. Okay, so I hope this is clear. So this was Engineer Manish Parmar, and now we move to the next question. This question is by Engineer Neeraj Kumar. He is a postgraduate student from Tamil Nadu, and he is asking, could you please explain in proper and clear step-by-step manner how to perform both static and dynamic analysis in StatPro, including how to define and assign static loads, where the reference load should be used for static analysis, how to define model mass. You can refer to some YouTube videos for this. You can refer to YouTube videos. Maybe you can go to the Bentley channel. Over there, they have some good videos uploaded, or you can go to YouTube videos by any other educator online, and you can find out the correct procedure for doing this. Okay, yeah. So I think that will be the easier way to do it. You go to any Bentley documentation, or go to the Bentley channel, or you refer to any YouTube video, or you go to the Bentley help menu, and they will give you this step by step procedure. And before that, you must have I mean, the theoretical framework should be clear in your mind. So you can refer to the IS 1893 before you go to these documentations. All right. Okay. Now, next question is from uh, who is this? Next question is from Engineer Deepak. He's from Kolkata and he's a working professional. He's asking, building is located in a hilly slope. What are the measures we can adopt, especially for high seismic zones? So let's say his building is like this. This is the road level, and now he wants to come up with a building. So what happens in these cases in hilly slopes? Number one is, uh, sorry. So number one is that you may have footings and column heights at different levels. It is a possibility that certain columns are at certain heights, and different columns, I mean, other columns are at a different height. There is a possibility of this. So maybe you had a hard strata, and let's say you were maintaining 1.5 meters. So okay, this is your situation, let's say. So what is happening, each column height is different over here. So number one care that you have to maintain, first of all, especially I'm talking about more from the perspective of seismic loads, lateral loads. So number one care is that how to calculate the time period. Now, when you have to calculate the time period for this situation in the IS 1893, even in the 2016 version, because now recently we have the 2025 version, but even in the 2016 version, you will get a time period formula for these types of you will get a time period formula for these types of system, where the column heights are different and the structure is on a slope. So you can refer to that time period formula. Okay, and then you have to be especially careful about the uh, bending moments and shear forces in the column for lateral load. Now, because these columns are of different height, you will see some differences in the bending moment shear forces in these columns. The stiffness changes. The stiffness of each column will change because the lengths are different or heights of the column are different. So ensure that those changes are considered in your analysis. So what I will suggest you is that if this is your situation, then you don't model it as if all columns were of same height. Don't do that. Okay. If your structure is on a slope, ensure that you also model it this way, where the different columns have different heights and support conditions are provided. Do it this way. So this is the number one thing. Now, second thing is that if your strata was not very stable and you had a poor strata, then this type of a situation is not recommended. And then what I will recommend you is that in this case, in case if your strata is not very good, then you go for a complete excavation like this. Okay, come till a base, proper base, and then ensure that all your footings are cast at the same level like this. Is this clear? So in most of the hilly regions in India, in Himalayan regions at least, your rock slopes are not very stable. So in such cases, what you should do, that you should uh, have these complete thing excavated, okay, and then place your footings on same depth. Same depth means something like this. So all columns will now have same heights, and you achieve a proper base. Now in these cases, you may have to go for a retaining wall over here to protect this slope, and maybe a toe wall over here to protect this slope also. So this type of a scheme may be required. Assume we are assuming over here that your slope is not very stable, so you will have to stabilize it by providing these retaining walls or toe walls. So these are some of the suggestions that I have for structures where you want to make them on slopes. Okay. Okay. The next question is from engineer Umang Patel. He's from Nashik, and he's a postgraduate student, and he's a very involved postgraduate student. He's doing his thesis in earthquake resistant steel structures. So he's saying for earthquake resistant design of steel structures, we provide bracings to beams to satisfy the slenderness ratio criteria. So there is a criteria given in 18168 and also in the uh, AISC 341 that you need to stabilize your beams. So let's say this is the beam which is going to take, which is part of your moment frame. These two beams are, let's say, part of your moment frames, special moment resisting frame, let's say. So there are requirements that you have to stabilize this beam by providing stability bracings. Okay. So now he is asking, by providing bracings, the effective length for lateral torsional buckling decreases. So why it will decrease? Because this effective length has reduced, leading to an increase in moment carrying capacity. So because this effective length has now reduced, the moment carrying capacity goes up. So if I design a beam having utilization ratio of 0.9, then after providing bracing, it reduces to 0.5. Then again, shall I change the section or not? Because then it will form a loop, since if we decrease this. Okay, so yeah, because your effective lengths, you are getting reduced effective lengths, you should not design it for this length to begin with, because then you will get in a loop. So my suggestion to you is to reduce the number of iterations. You find out the size only after you have a certain spacing between the bracing that you're going to provide. So you first figure out a tentative size, then you finalize the bracings, and then as per your bracing spacing, you find out the, or you finalize the beam size. So yes, there will be some iterations, but it will not be an infinite loop as you are assuming it to be. You will be able to fine tune it after 1 2 iterations, but to achieve economy, yes, you should do it. So you should take the advantage of smaller lateral torsional buckling lengths because of the bracing, and accordingly find out the size of the beam. And yes, for the size of the beam, then again there will be slight changes in the bracing sections, but after 1 or 2 iterations, and with some experience of doing it, you will be able to achieve a good convergence. So it's not going to be an infinite loop of iterations as you are thinking it to be. Okay. Okay, then we have next question is from engineer Padma Vijayan. He is from Salem, Tamil Nadu, and he is an independent consultant. So he is saying how to design a retaining wall on a rock surface when the surface is sloped and water is draining on it. So let's say he has a sloped rock surface. I'm not sure what he means by water is draining on it. And this is the retaining wall he wants to come up with. So see, if it's a rock surface, then you find out what is the phi, because then your phi values will be close to 90. That means the rock is not going to bear against uh, the retaining wall. Okay, so your angle of internal friction will be close to 90. That means when you calculate 1 minus sine phi upon 1 plus sine phi to calculate the Ka value will be very close to 0. That means the slope is self-stabilized and it's not going to push the retaining wall, or it's not going to press the retaining wall as would have been the case in a soil strata. So first of all, you find out the phi value. Phi value will be close to 90, meaning thereby that Ka will be very close to 0. So first of all, figure that out. Okay. And water is draining on it. I'm not sure what it means, but generally we can provide weep holes so that if there is water, it can just seep through and not create pressures on your wall. So uh, you can provide weep holes or holes so as to allow the water to seep through. So this is one of the common strategies that we adopt. And for the rock surface, I just told you, you first find out what is a tentative phi going to be. See, rock means it's not necessary that it will always have a phi close to 90. It will have some uh, it will have some phi value, so that you need to figure it out and then accordingly find out the Ka and then do the calculations. Okay. So the next question is from engineer Suraj Dhodari. He is from Bengaluru. He is a working professional. And what is he asking? Uh, as per the code for basement walls and podium level floors, it is required to provide modifiers as per lower bound and upper bound for integral models. But in my case, I have two basements and a retaining wall tops and ground level. I have podium floors up to the seventh floor and above floors are typical. In this case, for the seventh floor and below floors, shear walls, basement walls, columns, slab beams, which modifier I have to adopt? For basement floors, also, is it required to provide modifiers as per the upper bound and lower bound? If my basement wall is up to ground, the podium cover is on the seventh floor. That means I have to consider modifier. Correct? Very confusing question. I think you first need to understand why you are providing this upper bound, lower bound thing. Upper bound, lower bound, we are doing specially only in case of backstay analysis. In normal analysis procedure, when you are doing your normal analysis procedure, there is no thing like upper bound, lower bound. Okay. Only when you are doing backstay analysis, we are doing the lower bound, upper bound thing. So this is the first point that you need to understand. Okay. Now the basic principle is that whichever element, now I'm not talking about your question in particular, whichever element is helping in providing you a backstay, you provide or you provide the upper bound and lower bound modifiers for it. So for all the elements which are which are taking part in providing backstay, In providing backstay, you have to do the backstay analysis, and then you provide the upper bound and lower bound modifiers. Simple concept. So now you first see and how to judge which elements are providing you the backstay. So easiest way is you can just see the shear force distributions, especially in walls, and if there is a shear force reversal or if there is a shear force reduction under the effects of lateral load at some level, you can sort of understand that this particular elements and all the elements below them are providing the backstay. And if those are providing the backstay, then you assign the and then you sorry, if those elements are providing the backstay, then for those elements you perform the upper bound and lower bound analysis. Simple. Clear? Hello, I hope this is clear. Yeah, so don't get confused with the geometry. Keep in mind this simple concept. His next question is, in he has continued his question in continuation to my previous query. While assigning seismic parameters and matching base shear, is it required to match it at ground or based on the results of separate model? And for wind gust, how can I provide the wind shear? For separate tower, separate shears, and below seventh floor, I have to apply combined wind shear effects. I have not understood this. Not understood. For wind forces, applying wind forces in models combined with podiums, you refer to the last session. Refer to Ask AuxEn Anything session number 45, last session where we have dealt with this query uh, in parts, that is. So you can refer to that session, but I have not fully understood your question over here. Okay. All right. So these were the queries that were there on the Google form. Now let me take up the questions from the live comments because we don't have any question on the email. So let's now take the queries in the from the live comments. Uh, so Struct Architecture 2779 is asking what should be the slope of Y column or flared column. I don't think there is any such guideline or criteria. Whatever is the slope for the flared column that you have decided, you have to accordingly do the analysis of that flared or Y column and accordingly provide the detailing. I don't think there is any guideline as such. Okay. Then Mr. Magaj is asking, how can we decide that retaining wall is propped? How much slab area is required for the same? Example, if a 4-meter retaining wall has a support of 5-meter by 5-meter slab, then can we assume it as a propped cantilever? Oh, very good question he has asked. He is saying that, let's say, this was a retaining wall applied to certain pressures, and then there is a slab over here which is connected to that retaining wall. Okay. Now, what should be the stiffness of what should be the stiffness of this slab so that this retaining wall can be termed as a propped cantilever? You understood what he's saying? So one is the case where it's a cantilever, bending moment will be like this. Other case is that if it can be considered as a propped cantilever, your bending moments will reduce. So for what geometry or what should be the stiffness of this connecting element so as to decide or so as to decide that your retaining wall is now behaving as a propped cantilever and not a pure cantilever. That is his query. Very good. So I think number one is that this should be held. This slab element should be held in position. It should not be that it is also moving or it is free to translate. That is, I think, the number one thing that you should ensure. Secondly, I'm not sure how to find it out. Some sort of axial stiffness we have to calculate. We will have to calculate. So, mm, very good. I have to think how to uh, judge. So, based on the axial stiffness that your element is going to provide, you can judge. So, number one is, as I just told, that this slab element that you're having, horizontal slab element, that in turn should be in place. It should not translate, or it should not be free to move. So, that is one thing. Now, the next point is, okay, so a practical way of doing it in analytically is, you put a spring stiffness over here, you put a spring over here, okay, and assign certain stiffness value in analysis, ETAB, stat, whatever you are doing. Make a simple line model, assign a spring, and assign a certain stiffness to it. You apply the apply the lateral loads. Now you know that what will be the moment in case it is a cantilever. Okay, I think if it is subjected to a triangular load W, sorry, if it is subjected to, let's say, a triangular load Ka gamma S into H, you will know how much moment it will have, isn't it? And from simple formula, you can also find out how much moment it will have if it is a propped cantilever. You will get those values quite easily. So now you apply that pressure over here, you check what is the moment value. Now, if that moment value, let's put some figures. So let's say the in case of free cantilever moment, the moment was around 100, and in case of a propped cantilever, the moment was around, I don't have the values with me, but let's say it was 40. Now you do this analysis, and if your moment comes to, please remember you have assigned a spring over here with a certain initial stiffness given to it. So now if your moment comes to close to, let's say, 90 kilonewton meter, so what you will understand, that this spring is quite weak and the behavior is close to cantilever, pure cantilever. So now you adjust this spring stiffness value maybe to a higher value. Then you run the analysis, again check the moment. So you keep on doing it till you reach a value which is close to your expected propped cantilever moment. Now at that particular value, you can find out the axial force in the spring. I hope this is making sense. You can find out the axial force in the spring. Now, so you take this axial force in the spring that you are getting, and then you design your horizontal element and ensure that it is able to safely take that particular axial force. So I think this is the way in which you can do or perform such an analysis. I hope it's clear. Continuing, can we design the slab as a water beam? What is water beam? Oh, Whaler beam. What is Whaler beam? I'm not sure what is Whaler beam. But I think this process you can apply, and by assigning a spring, you can just get the axial force in that spring, and accordingly you can figure out that, okay, this is the axial force which needs to be safely taken by your let's say the slab or beam, whatever, and then design your beam or slab for that particular axial force. So this is the way in which you can do it. Good. Next question is from engineer Saurabh Srivastav. He is asking, I wanted to ask about connection design of hollow sections with I sections in AISC code where connection design provision is given. I am enrolled in AI. Yeah, I know you have enrolled in the AISC course. So see, hollow section to hollow section to hollow section is covered in chapter J, no, chapter K of AISC. Okay. Normal section connections are covered in chapter J. Now, hollow 2I is not covered as such in any of the chapters. So, you will have to apply the concepts that you have learned in chapter J and K to the condition where a hollow section is attached to an I section. And then you can apply those concepts. You must have learned, as we have discussed in the course on the AISC, the idea statica modeling and calculations. So as per that, then you can come up with the uh, connection design for such a situation. Okay. Okay. So this was engineer Saurabh Srivastav, and engineer Hiren Desai is asking if there are three towers coming up from common three-story podium, how to analyze and which time period formula to be used. So time period, it's not quite clearly given in the IS codes, but then uh, you can refer to the time period formulae, although it does not cover the common podium case. But then let's say these are three towers on a common podium. You can refer to the height. Uh, you can refer to the heights to be adopted for time period calculations, whether they are connected or not. From there, you can refer to IS 1893 and find whether this height is to be taken or height right till the bottom is to be taken. From there, you calculate the time period. Okay. And then how to analyze. So for analysis, we have discussed these questions many times in the previous sessions also. Maybe you will have to first create some small standalone models, find out the earthquake forces at each level, and then come back to your main model and then apply those forces in the main model. So you will have to do a jugaad process like this in case of uh, structures connected to common podiums. What should be the slope of? Okay, so he has put an image, but as I just told you, the slope, there is no restriction on the slope as such, or there is no guideline on the slope as such. So, so I have not come across any guideline, but maybe I think some principles of strut tie methods can be used over here. That what is the slope so that the load can flow to the column through this zone. But at this instant in time, I'm not very sure about the criteria for this slope of the flared column. Okay. His second question is, why do PEB companies in India design as per the American codes? Because of lack of knowledge, because of lack of understanding of the code, they will design it as per the See, designing as per the American standard is not such a big problem. The bigger problem is taking the wind loads and lateral earthquake loads from ASCE, which are at different risk levels, and then using the Indian combinations, and then no. So what they effectively do is that no, they do it even worse actually. That they will take the wind speeds, okay, and EQ zones from IS standards, Indian standards. Now these are at lower levels or at lower mean recurrence intervals. So Indian standard wind speeds and Indian standard earthquake values zone factors are for lower level mean recurrence interval. So the magnitude of earthquake forces and wind forces are lower in the Indian standard. Now if you compare it with the American standards, the wind speed and earthquake forces are for a greater MRI mean recurrence interval. So their wind forces and earthquake forces are of a larger magnitude. Now how do they take this into account? So their load combinations will be like this. For example, okay, so their load combinations will be something like this. Our load combinations with Indian standard will be like this. Okay, or maybe 1.5 dead plus 1.5 EQ. Their combination will be 1.5 dead plus or 1.2 dead, I think, plus 1 EQ. So what's happening, because the American code wind and earthquake magnitudes were greater because of the mean recurrence interval that they are taking, they apply a lesser multiplication factor. In the Indian standard, because we are calculating the wind and earthquake forces for a lower mean recurrence interval, our values are lesser. Therefore, we apply a greater multiplication factor in the load combinations. Now, what these PEB companies are doing, that they are taking the wind speeds and EQ as per the Indian standard. So they are taking a lower magnitude of wind and earthquake forces, because remember, we are in the Indian standard, we are considering it for a lower mean recurrence interval. So they are taking a lower value of earthquake forces, and then they are using the load combinations of American. So they are multiplying it by a smaller combination factor. So this is the mistake that they are committing. Understood? This is the mistake that they are committing. So if you want to design it as per American codes, let's say you design it as per American codes, but then you take the lateral loads for wind and earthquake also for a corresponding higher mean recurrence interval. So let's say even in Indian project, if you want to use the American code, you ensure that the lateral load values for wind earthquake are taken corresponding to that mean recurrence interval, similar to what you have in the American. So now the latest code IS 1893 2025, it has uh, modified the values of earthquake and earthquake forces as per greater mean recurrence periods. So that is the problem actually. Okay. Mr. Soham Trivedi is asking, I asked question yesterday on WhatsApp regarding truss effective length. Okay, he had asked a question. Let me see what he had asked. Uh, so, okay, he has put this image. How to rotate this? Rotation. Just a minute. So this question is by engineer Soham Trivedi. What he is saying, this is a pipe bridge This is his top chord, mid chord, bottom chord. In minor direction, tie at every 3 meters. Question: what should be Lx, Ly, Lz of top chord? So for top chord, about one axis, I'm not sure which is x, which is y in this case. So let us say the cross section of your top chord was like this. Cross section of your top chord was like this. So let's call this as the x-x axis. This is the y-y axis. So about the x-x axis, you take the effective length factors as per these spacings between the vertical members. So that will become your effective length factor about the x-x axis. For effective length factor about the y-y axis, you take the effective length. Okay, you are calling it as the z. So effective length about the z axis, you take it as per the distance between these members. For the minor axis yy, you will have to consider the lateral direction members that you have provided. And as you are saying, they have been provided at every 3 meters. So I'm assuming at every 3 meters, you are tying the top chord about the yy axis. So in that case, then the ly becomes 3 meters, lz becomes this distance between the vertical members. Okay. Same thing will be for the bottom chord. Same logic you will have to apply for the mid chord. So first see what are the about the y-y axis, at what spacings you have tied your top chord, middle chord, bottom chord. Accordingly, you will have to decide your effective lengths. For the effective lengths about the major axis, the distance between vertical members can be taken as the appropriate effective length values. Okay, so this was his query. Then any design parameter or member specification that I'm missing, in my opinion, do not apply a truss specification because you are not going to provide actual pin-like supports. Okay, in your actual connection that you will provide. So therefore, do not take these truss specifications to any of the members. Anyway, because of the geometry, there will be very little axial forces, sorry, very little movements in the members, but design those connections for those movements. Do not assign any truss specification. All right. Okay, so this was Engineer Soham Trivedi. Mr. Magaj is providing this information related to his earlier query. This was his query. A Wheeler beam is a horizontal structural component used in construction to provide support, distribute loads, and maintain the stability of vertical elements like formwork or retaining walls. Very good. 1/6 of slope or 0.2 L. I'm not sure what this means. Mr. Hiren Desai is asking any reference or books or guidelines for such structures, towers, and common podiums. I am not sure of any documentation for this. Maybe someone in the live audience can provide some inputs for towers on common podiums. What to do? Mr. Saurav Srivastava is asking, are there any provisions given for hollow section and base plate connections in AISC code? No, you just follow the guidelines of chapter K and refer to our course where we have done the base plate design for hollow sections also. And other than that, just follow the guidelines for hollow sections in chapter K. Mr. Ajinkya is asking, we designed the backstay diaphragm for axial forces generated out of the backstay effect, but these forces ultimately go to retaining wall. How do we design the retaining wall for these forces? So you design your retaining wall for the horizontal axial force and out of plane bending moments. So good way to do that is to assign pier labels. So let's say in section, this was the basement wall and this was his diaphragm and this was his column tower, let's say, and the backstay forces are flowing and going to this. So I am saying that you assign pier labels By assigning peer labels, what happens is that ETABS will then begin to consider the axial forces, and it will anyway consider the out of plane moments also. So good way is that, let me just make a plan view. So let's say this is my basement wall, and then there was a diaphragm like this, and this was the tower portion. Now the backstay forces are flowing and going into the basement wall. So I am saying that if it's a slab, let's say if it's a continuous, if it's a slab, then maybe for a 1 meter width, you can assign a pier label to this wall, basement wall, and then you will get to know the forces, actual forces flowing into this pier, and you will also have the moments, out of plane moments, and automatically your software like etabs will be able to design your pier for the actual forces and out of plane moments. If it's a case of beam, let's say if you had a single beam, then maybe considering around 45-degree angle of dispersion, sort of what you have been given in the collector chord elements, you can come up with the this dimension of the wall, which is going to be effective in taking the axial forces from the beam, and then assign that much dimension of the wall or that much portion of the wall as a pier label, and then again design your basement wall for it. So in our course on tall buildings, we have done these things while discussing the backstay effect. Okay, then Mr. Harish Acharya is asking, the new 1893 has been published just last week, so please make a new course about this update. Yes, it has been the course, sorry, the code has been revised just last week, so I have not yet gone time to go through it. So once I go through it, once we go through it, and once we have updates in the software also, we will try to come up with a updated course. Mr. Harish Acharya is asking how to model flaring in shear walls and how to model transfer beams with floating columns in EDAPS. So transfer beam, you can just model it as a line element, or if it's more complex, you can model it as a shell element also. So the depth of the beam will be as per the, so according to depth of beam, you can provide the elements. You can provide actual meshing like this, and whatever is the depth of the beam, accordingly you can come up with the uh, shell elements over here, and then the thickness of this shell elements will become the width of the beam. So that is one way, or you just model it as a line element, and even that will be possible. And flaring in shear walls, you're asking again, same thing. You can just model your shear wall in this way. Now I'm showing you the elevational view. So you can come up with the modeling of shear wall in this way. Do the meshing in such a way that over here there are more number of elements, and this dimension is larger over here, smaller over here. Okay. All right. So I think those were the queries for this week. We have taken all the queries from the live comments and from the Google form. So throughout the week, if you have any queries, I think there was one query that was asked by engineer Manish Parmar. Is it possible to provide fillet weld in between two connecting legs? Mr. Manish has told you on WhatsApp message also to provide some supporting sketch or screenshot. I have not fully understood between which legs you want to provide a fillet weld. So provide some sketch or section over there. Yeah, I just answered. You provide a supporting sketch. You did not provide me a supporting sketch or any screenshot that I had asked you for. And your earlier query we have already taken. Your earlier query we have already taken, which was this query regarding the effective length calculation. So that was the first thing that we, second thing that we discussed today. Okay. All right. So throughout the week, if you have any further queries, you can always put it in the live comments. And once every week, when we meet, we will take up your queries. Uh, throughout the week, if you have any comments, you can put it in the Google form. And once every week, uh, we will take them over here for discussion. The link for Google form remains the same. Okay, so this is the link for Google form. And if you want to uh, connect with us on WhatsApp, then this is the link. I have just put it in the live comments to connect with us on WhatsApp. So I think this is all for this week. Thank you. And now we will meet again next week with further queries that you may have. All right. Thank you. Bye bye.